Welcome to the fourth section of this course in which we will be building a smart video player. This app will give smart capabilities to any standard video player. When I say smart, I mean that the app will be able to pause the video playback if it senses that the user is not looking at the screen. It will also resume the playback when the user looks back at the screen. We will send signals from our Python application to the video player or media player through a little bit of GUI automation. In order to give our app that smart capability, we would need to track the face of the user, and that is exactly what we will be talking about in this video. In order to give our app that smart capability, we would need to track the face of the user, and that is exactly what we will be talking about in this video. We will write an app which is able to detect the face in a live video stream using something called as a Haar Cascade. But what is a Haar Cascade? On a very high level, a Haar Cascade is a machine learning model which can be used to detect any object in images or videos. Using this approach, the model will learn by itself by studying a large dataset of a particular type of object. So let's assume in our case, we wish to detect faces. We would want to train our model on thousands of images of faces, also known as positive samples, and also on thousands of negative samples, or in other words, images which do not have faces in them. While training, the model would automatically pick up relevant features from the images, which it thinks best distinguishes the face from other objects. These features can be edges, lines, etc. The training process takes a long time depending on the size and number of images. It can even go to many hours and would require significant computational power. Luckily for us, OpenCV provides a pre-trained Haar Cascade for faces, eyes, and many other objects, which we can use right out of the box without the need to retrain it. These Haar Cascades are stored in the XML format. Now it's time for the best part, which is to write some code. So I've made a new folder called Smart Video Player, and inside of that I've made a new file called smartvideoplayer.py. And inside of that, this is a plain template of a program which reads from the webcam and just displays it. Also, I've made a grayscale image by converting the input frame which we read and converting that to gray. Now, in order to detect faces in a live video stream, we would need to do two things. First up, we would need the pre-trained Haar Cascade for detecting faces, and the second one would be that we use that model and detect faces in the live video stream. And in order for us to equip our program with those capabilities, we only need to add a few more lines. So the first line over here, it initializes a new cascade classifier by reading this particular file here. This file will be found in the code bundle for this section. So as the name suggests, this Haar Cascade is for the face and it's in the XML format. Next up, in the loop, after we convert our input frame into grayscale, we pass the grayscale image into a function called detect multiscale. This function is a part of the face cascade object which we just initialized earlier. So this function takes in three parameters. The first parameter is the grayscale image of the image where we want to find our faces. The second parameter is a scaling factor which denotes the percentage to rescale or resize in each iteration of this function. So in this case, we have it as 1.1, which means that in every iteration, we reduce the size of the image by 10%. And the last parameter here is the minimum neighbors parameter, and we've set that to 5. This parameter specifies how many neighbors each candidate rectangle should have in order to retain it. So as a rule of thumb, the higher the value of this minimum neighbors parameter, the lesser the detections will be, but they will be more accurate. The lower this value, there will be a lot of more false detections. So in this case, we've set it to a medium 5. So this function returns us a list of lists. So each element of this list is another list which contains 4 numbers. These 4 numbers are the x coordinate of the top left of the rectangle, the y coordinate of the top left of the rectangle, and the width and the height of the rectangle. This rectangle denotes the area in which our face was detected. Next up, we will iterate over our faces variable. We will say that for every face which we detect, we grab the x, the y, the width and the height of the rectangle of that face and draw a rectangle using the cv2.rectangle function by specifying where we want to draw the rectangle, what is the top left coordinate of a rectangle, and what is the bottom right coordinate of a rectangle, which is denoted by x plus w, y plus h. We will also specify the color of the rectangle which we wish to draw and the thickness of the line we use to draw the rectangle. And then normally we can use the cv2.imshow function to display what we get. So in order to test out our program, we can go back to the virtual workspace we created and cd into the smart video player directory. Inside that directory, we can call python3 with the smartvideoplayer.py file.